All right. Is some sort of serialization easier with this language? Yes, it is tremendously easier than in C++. I have demoed that on YouTube several times. If you go back, maybe somebody can paste a link to the demos where we do serialization. What code gets generated for setting struct defaults? Is it like a mem copy from an exemplar, or is it just regular assignments? Right now, it is regular assignments, but it doesn't have to be that. You know, like, I think probably the right solution is some heuristic that says, how many assignments are we doing? You know, if it's, if it's like 4 or 5 assignments, just do the assignments. But if it's a lot more, then we mem copy from an exemplar, right? But that's, that's sort of a level of optimization that we're not really worrying about yet. And it's also like, it's kind of easy to do. Oh, there is one exception, right? The exception is if the struct is all 0, then we just, mem set it to 0, right? Or not mem set, but like we just wipe zeros across it. We don't store zeros in all the slots, right? So that's the lowest hanging fruit thing. But yeah, mem copy from an exemplar is definitely an option. That might even be a thing that we let you specify how it happens later on, although we don't have any mechanism for that right now. Will unions have safety and debug modes so that you cannot accidentally use the wrong union value? In Zig, you have a secret field for the tag to provide the safety check, similar to array bounds checking. Oh, you mean like when you set the union, you get one thing, it sets the tag? The thing about that is it'll break because you might, for any programming where you directly access memory, you might just like lay that union or just have some bytes, and especially if you loaded in a serialized file that's just binary data that's full of relative pointers and stuff, you might just return a pointer to a union. It's not going to have that tag in there. You can't change the size of the union in that case because you'll just screw up everybody's code. So no, we don't do that. Someone asked about the difference between constructor and initializer. The initializer is just all the static values that don't require runtime code to happen, right? And the constructor is just an arbitrary procedure that is declared by the user that's Turing complete and may go off and do whatever, right? And so just for cleanliness, we factored those into 2 separate things. So because my intuition is that you may want to use them separately. That might be wrong. I don't know. We'll see how it goes. Are there plans for improving threading parallelism? I have not seen any good ideas for how to do threading better. If anyone has good ideas, let me know, but I haven't seen any, honestly. Aside from, there's some simple things. There's 2 things. One is you can help people know that their threaded code doesn't use variables outside where they're supposed to, which you can already do with a compile time metaprogram, but we might make that easier. And the other thing is maybe adding some mutex help so that you say this variable, you have to be holding this mutex to access this variable, which is fine, except that real high performance threading doesn't use mutexes a lot of the time, so that's only helping beginner threading, right? Please don't say like channels like Go or anything like that, because that's not high performance threaded programming. Can struct literals be type inferred into anonymous structs, sort of like a tuple? I don't know if I want to allow that. Maybe. I mean, there's certainly no technical barrier to doing that. It's just once you have a lot of that kind of thing floating around and you're relying on the optimizer to get rid of it or something, that's bad. And so I don't want to set a tradition of that kind of thing. Do example of print the type of member of struct when procedure is passed a pointer. Yeah, I could do that. Let me do that real fast, just because I said we could do that during the Q&A. So the whole thing that's going on here is just, I don't quite have exactly the right API here. What I have is this print type to builder. So here's what I can do, is I can say builder is a string builder. Print type to builder, it dot type, and then I forget what string builder we say, builder to string. I'm just going to put that in temporary storage so I don't have to free it. And then like that. Whoops, I'm in the wrong console. So where is that? There we go. I should have just done that during the stream, because it really only took a second. It's just I didn't want to stop and think about it, right? So we have an A. Actually, you know what? Instead of saying all this member type, I can just print it in language syntax, right? So I'm just going to say name colon type. It'll be easier to read. There we go. A float 32, B float 64, CS 32, position vector 2, bitmap string. In fact, we can put a semicolon. It'll look a lot like code if we do that. So, you know, like I said, this stuff isn't hard. It's just, it just took an extra second, and I didn't want to think about it. Any plans to support runtime polymorphic interfaces, as in Go, for example? Well, I certainly would like the language to be powerful enough that you could implement that if you want at user level, and you know, maybe we'll provide a user level library for that or something. But no, that's too slow for our purposes to want that to be in the core language semantics. Definitely, so someone said it's really refreshing to see a programmer getting excited about programming for once. That is why I started doing this language, is because I got so depressed about using C++. I wanted something better. I wanted to be happy again when programming like I was in the 80s. If you have a function that takes a union, can you pass a variable that has a type included in that union? No. You would have to cast it to the union yourself first. What's the concurrency multi-threading story? The story is that we provide some basic stuff like mutexes and whatever, but like I said, I've never seen, like all these things that people are saying that their language helps with threading, none of them actually work for real programs that have to go fast. What's the syntax for checking if flag is set? Same as C? Yeah, it's currently the same as C, although frankly that's not really my favorite part of C syntax, and so we might change that up. Will we make our own linker for the final release? Well, here's the thing. If you're going to link in any external C libraries or libraries written in other languages written by somebody else, and you want to statically link them, as opposed to dynamically linking them, then I don't know if we're going to handle that, because that's like writing a whole linker at that point. I don't know if we would do that, but for the part of your program that's just your program here, that I think we can pretty easily, you know, just link that ourselves, and it'll be tremendously faster than calling the system linker, because those things are terrible. So yeah, that's the plan. Do I have any idea about how much until this gets released? I said that at the start of the stream. Someone who came in late, I guess. Throughout the talk, you used the term type while the keyword was struct. Why is the keyword not type? No, I don't think I used it that way. No, a struct is, when you make a struct, it declares a new type, but there are other types besides struct, right? There's float, there's enum, there's procedure types, right? So making a struct makes a new type, but it makes a struct type. Ignoring JavaScript question. It makes sense to have a C ABI union type, but it also makes sense to have a native union type that does not make guarantees about how big the size is. It's useful to know what the programmer intends to do. Imagine if you had one way to assign a different field to the union and one way to reinterpret the union value. This clarity of intention lets the compiler understand what the programmer wants and then do the optimal correct thing. Super Joe 30. I'm not sure I understand exactly how this helps, so if you maybe wanted to give me an example, then I could think about it. I was thinking about giving a language talk at GDC, but I decided against it. Like giving a talk at the GDC is a pain in the ass. Last time I did it, they ruined my talk. And I've just been mad at them ever since then for like 6 years or whatever. More than that now. What about an error handling standard or external library metaprogramming function that scans the code for unhandled errors and gives us a warning that tells us which error is reported by the called code or not handled by the calling code? So you mean like exception handling for language errors? I've thought about that, but I think that's maybe a little bit weird enough that it's not going to go in version 1 of the language. We'll see. Like, I think we need some good experience with the feature set we have that's unlike the way everyone else does things before we do things that are too crazy. Will it be possible to compile the WebAssembly? Probably, because we have an LLVM backend and people have LLVM to WebAssembly things. Since types are also values, why would you use the enum value door instead of the type value door? Says James Widman. That's a good question. The reason I did it in this example, so this is generally something, there are 2 reasons to do that. And this is something that I have unresolved in the long term, but I don't have a good answer for it in the short term, right? So reason number 1 is the following. I can declare the size of an enum, and I can make it as small as I want, right? So these are 1 byte tags, and so I can, fit more stuff. Whereas if you said, type equals door or whatever, you can certainly do that. And in fact, I do that in the Sokoban code base. The problem is that turns into like 8 bytes or 4 bytes. I forget what it is right now. So that's thing number 1. So that's just a little bit of a tweaky optimization. But thing number 2, which is the bigger issue, is that when you do this, you can control serialization. And these numbers will not change unless you explicitly change them, right? Which is also why I'm not letting the enum auto-increment this. And I suspect that letting enum auto-increment is actually going to be considered bad form, and maybe we'll even take it out unless you explicitly say by default with an extra directive that you want to do that. And the reason is because you don't want things accidentally changing if you're going to serialize and deserialize something. Although instead of making auto-increment be bad form, maybe when we serialize, we always write a dictionary of all the enum values and stuff. But that makes the files bigger, and it makes reading and writing them slower. So it's unclear what the best choice is there. But anyway, so the problem is if you use a straight up type name someplace like this, that doesn't correspond to an integer necessarily, right? It just corresponds to a string that we then, the number of which might change. So then if you serialize it, you have to serialize and deserialize a string, which is slower. And then you might one day just want to change the name of some type in your program because you're just refactoring the program, and now your serialized thing doesn't work anymore, right? That's a very annoying and mysterious breakage. What the hell happened? And you might not even notice if you didn't try to load some particular file that it doesn't load anymore. So I want to stay away from invisible breakages like that. It's a very good question because obviously the simplest thing to do is just use the type here. But I don't want to start telling people to do things that are going to end up being giant landmines or foot guns in the future. And that is a potential foot gun at some level. For talk about backends, you can watch previous streams. We've talked about that a lot. What are my thoughts on adding a package manager? We're going to talk about that next time in the library stream. What license will we use? It'll be some variant of a very free license. It won't be GPL. It'll be, something like MIT or BSD or whatever the newer versions of those are. It won't be any of this GNU bullshit. Can initializer constants be replaced by run calls to functions that return the proper types? Yes, they can. So for example, you could generate a random number or something. The only thing is, if you're declaring a type here and you generate a random number here, keep in mind that's only going to get generated once, right? It's not going to get generated every time you instantiate the struct. But yes. Will there be closures for GA? I don't know what GA means. Will there be closures? Maybe. It's kind of been my plan to implement closures for a long time. But they're just not very high on the list of things that I actually want, especially once I have all these other very powerful features. We probably will do closures eventually, but I don't exactly know when. Do you have a public email? Let me talk about the email. What was my file called? January progress report. So this is the email where you can contact me. This is not a mailing list. It just goes straight to me. I don't reply to many of the emails that go here just because I have a lot to do, and writing replies to everything takes a long time. But I do read everything that goes here, or most things. Sometimes if somebody gets really excessively spammy, I stop reading what they send, but most reasonable emails to this address I will read. How hard is it to make the compiler work with ARM? Could that be the console architecture you mentioned earlier? I'm thinking about x64 consoles in the beginning just to make it easier. With the LLVM backend, you can certainly target ARM today even. Maybe we should do that as a proof of concept. That won't be the fast backend, but it's not that slow. It's not an order of magnitude slower compilation or anything, so it's fine. Will I ever finish the talk that got cut short at GDC? Probably not. Probably not. Can I just print %struct x:(s32)? Yes, but it'll just say anonymous struct right now. It won't, because you're passing the type, and the type is an anonymous struct. You could certainly make print out all the detail of that anonymous struct, but it doesn't do that by default right now. It's unclear, you don't want your print to recurse infinitely through pointers and everything, because it'll infinite loop if you pass it certain kinds of things. And so there needs to be a policy about, and also if it's too verbose, then it's just annoying. So there needs to be a policy about what print prints by default and how much information it gives you. And maybe you could pass it some flags to have it do more information. I don't know. I don't think you can use MIT and at the same time protect against MS taking over or anything like that. It's a good point. I feel like there are people who have threaded that needle though and done like a license where it's free except prevents, embrace, extend kind of things. So we need to research that and find the right thing, you know. Because we don't want to force you to publish source code in order to use it or anything like that. We don't want any restrictions on commercial or non-commercial use. However, we want to defend against corporate Goliaths, right? So I need to consult with some people about that. It's kind of sad, but that's actually the biggest technical barrier to release, is figuring that out. Is being leet good or bad now? I don't know what that means. An example of how an error handling guarantee could work: if errors are reported using multiple return values, get all the return statements and extract the error values and check if the caller uses those specific values in if statements. Yeah, maybe. I mean, we'll look at that sort of thing later. It's just that's beyond the scope of the initial release for sure. Do programs ship with the C runtime? Right now they do, just because we still use some C things, like we use C's malloc right now, which is bad not just because it requires the C runtime, but also because it's different on every machine. So, you know, I want to instead use TC malloc compiled without a runtime, assuming we can manage that or whatever, right? Our support libraries are currently in C, it's compiled in C and stuff, and it's probably annoying to try to get the C library out of that, but it's not that annoying. So aside from very small connection between the support libraries and the allocator and stuff, I'll just say we have very small dependencies on the C runtime, and we're not growing those dependencies over time because the plan is to be able to eliminate it eventually. It's just that we're not yet at the stage where we can eliminate it. But it's not like Rust or something where we assume the C runtime is going to be there forever. No. Part of the whole point is that we're simplifying things, and to simplify things, you have to decrease the size of the junk pile, right? Not increase it. That said, on places like Linux or whatever, apparently you can't even start a process without the C runtime, which is absurd, and I hope they factor that apart in the future and fix that. So on Linux, I don't think we can do anything, but on Windows, we definitely can. Besides OpenGL, what other graphics APIs will be supported? I don't know. Out of the box, I don't know, but people will certainly be able to use other people's code that interfaces with anything. On day one, you'll be able to write a simple C-tags meta program so you can actually navigate the code easily. Yeah, I mean, I might even provide an example of a program that, because I don't even know what the C-tags format is or whatever, but certainly editor integration is going to be a thing that a lot of people are interested in, especially early on. So I might just write a simple library routine that just outputs the locations of all your identifiers into a dumb text program, text file, where the format is obvious. And then people can just adapt that, just paste that and adapt it to whatever they want. It'll save people time. Are there type declarations for a return type of a function? Yes. If so, do we use type inference? Yes, but we don't infer return types. Plans for Vulkan bindings. I'm not going to do Vulkan bindings, but probably someone will. Are there any lines that can run non-deterministically, like calling two functions in C and adding their results together, which function runs first, etc.? Anything that is non-deterministic. I mean, I guess, so there are certain things that we haven't specified. Like, for example, I believe in C, it is not specified in what order the arguments to a procedure are evaluated. And I assume that we're going to stay the same there. So that's technically non-deterministic, except that the compiler probably will be consistent about that. And certainly it would be consistent over different runs of the program. So, I don't know. I mean, obviously you can write some code that spawns threads and does that, clearly, but apart from that, I don't know. How is the state about metal on macOS? We haven't done any metal bindings, but someone probably will. Was there ever a definitive decision made about how iterators would be arranged? Yeah, iterators are going to use that new macro facility that I talked about. That's actually another reason why I want to do them before the release. So like the style of iterators that I demoed is like a simplified C++ style. It's still way more code than I think it should be just to do a simple iterator. So I'm trying to get that simple and fast. Like if you want to declare an iterator for your data structures and they only in principle have to do a few lines of logic, then the iterator should only be a few lines of code, right? So I think I've mostly worked out the problems in how to do that, and we'll see. Someone is asking, in the instantiate and print example, how does static analysis work when value could have any type? Oh, I tried to explain that during the thing. The point is, this $ in front of t means that you can't call it with an unknown type. So let me do the following thing. If I say f is float, right? So float is a type. So f, let me make it explicit. F is something of type that equals float, right? So that'll compile. Let's just show that that compiles. Oh, wait, redeclaration of f, right. Let's call it some type. Right. So that compiles. So now if I say instantiate and print some type, that won't work. Oh, wait, it does work. What? That's a bug. Okay, that's a bug. I'm putting that on the to-do list. That's not supposed to work. Sometimes we break things. All right. It's not supposed to work because what it's supposed to say is, look, this value has to be known statically at runtime, and this actually isn't, because this could have been assigned to something else. Like what? Where is that? Yeah, well, it worked for some reason. That really shouldn't have worked. Okay. But the way it works is that it did work because it just assumed it knew the value of this was float, but that's not correct. Like, yeah. But the way it works is we just recompile this procedure for any new, for whatever value is, for whatever value of type that is passed in, we recompile this for that type, essentially. But we deduplicate. So if you pass in like float 10 times, we don't compile it 10 times. We only compile it once. Are there going to be changes to the switch statement to make it more consistent with the rest of the language? If I didn't answer an email about that, it's probably because I thought it was too much about syntax, and I don't care about syntax right Is it easy to call functions from C libraries? Yes, I do it all the time. There are many demos on YouTube showing that as well. After all the dev time, do you still have a solid visualization of the logic flow of the compiled parts? Yeah, if you mean in my head, yeah. And in fact, it's better now because I've been simplifying the compiler whenever possible, so I understand it better because it's simpler, too. Can you define types that don't accept null or zero? I guess it depends on what you mean by don't accept. You definitely could do a compile time metaprogram that every time you assign to something of that type, you could insert code that checks that the thing that you assigned was not zero. That would be the way, that's the first thing off my head that you could do. As for other things you could do, I'm not sure. There probably are some other things you could do. It depends on like exactly what your end goal is. Have you done any experiments with language translation, like converting to GLSL, HLSL? Not yet, but I have been, I don't know if you've caught any of this, but I do have this program print library that I'm supplying. It's not done yet, but you know, it's 800, 900 lines now. And what this does is it prints from the syntax tree back out to the textual representation of the code. And the goal is to work on this until it fully runs correctly. And then people could use this as a template, right? So then if you want to cross-compile this language into anything else, you know that this code correctly handles all the syntax tree nodes, and then you just change the output, right? So that's the plan. I want to provide people something like this. Any thoughts on optional types and monadic error handling? Monadic error handling doesn't mean anything. Monads, as far as I understand, because you cannot get any functional language person to explain a monad like a regular human being. As far as I can tell, a monad is just a way of creating a statically type-checked abstraction barrier between two parts of your program. That's like all it is. So monadic error checking is like just like everything else that we have. It doesn't make sense. If you mean like algebraic types, no, we're not doing that yet, and we're unlikely to do anything in that direction, except maybe non-nullable pointers as a special case. But even that is very questionable. What about tools? You think about a profile? Yeah, we'll do tons of tools. I talk about those all the time. Of course, tools take time to make. Are templatized atomics going to be part of this? No, they won't be templatized, because I think that's a garbage way to do it. Like, you don't want your atomics to be a template. That's ridiculous. What you want them to be is compiler-level built-ins, right? The reason they're templates in C++ is because C++ just went insane and refuses to add things to the core language that really should be in the core language, right? Saying this integer is atomic should not have to be a template. It should be the compiler knows that that integer is atomic and emits the correct lock instructions around access to it, right? And so that's how we're going to do it. It'll be just something like this. I mean, I haven't thought about it that much, but my thought so far is the following. Let's go to some declaration that's pretty simple. Like here, you can say atomic, right? And atomic. This one's a little hairier because a string is not one value, so I don't know if we'll allow that, but you know, these we would definitely allow, right? So it'll be like that, and it won't cause a template to happen because that's stupid. Did the compiler see that it has never changed from float, or does the compiler not do that kind of stuff yet? Even if it did that kind of stuff, which it doesn't, we don't do that kind of data flow analysis that earlier in the pipeline. It's not good to allow people to do that because you can't always rely on data flow analysis to know for sure what's happening. And so you end up in a very weird realm of language semantics, right? So the thing that is supposed to work is if you do this, that's declared as a constant and it can never change, and then we're allowed to substitute this. But the bug is, for some reason, we're substituting that. We're treating that as though it's constant, maybe because it's a type. I don't know. Maybe I accidentally broke handling of this in some way. I need to investigate, but it's really, even though it's obvious to any human reader that we know what this is, technically you're not supposed to know what this is because any code inserted in between here could change it. Do we have any tests that check the compiler correctly errors? We don't yet, but we want to eventually because quality of error messages is going to be very important. So, you know, pretty soon, we're still working on the tests that make sure the language semantics work correctly, but eventually we'll expand it to making sure that for all these various cases, the error messages that it generates are intelligible and good. Now, of course, error messages change over time and stuff, so that probably has to be something that humans check. But yeah. How quickly does Sokoban compile? It still compiles under 1 second, but it's taking more time as we add more code and stuff. I want to do another profiling pass soon and get it cut way down. The Microsoft linker is still more than half the compile time, though. Do I expect the speed to remain the same, increase or decrease as the project size increases per line? I think, you know, programs are always super linear. Like they grow, the compile time probably grows slightly more than the number of lines. But I believe we can probably keep that exponent very small, like very, very close to 1. And in fact, yeah, probably 1 for all intents and purposes. But we'll see. I don't know. Is the syntax going to change, or am I going to leave it the way it is? It's going to change. And that's one reason why I don't want to have that many early adopters, because I want to be able to change the syntax without hosing too many people. That said, I do want to supply a way for people to rewrite their programs into the new syntax, which is one of the reasons we're doing that program print library. Can I summarize the design of the parser? It's a parser using regular code. Parsers aren't hard. Remonads, you just mean like stringing together statements that depend on the result of a previous operation succeeded. Of course, you can write if ret equals success after every function call, but that is error prone and tedious. No, I don't agree that that is error prone and tedious. In fact, I think the other way around is error prone. And we can have a long rant about that later, but the least error prone thing is to handle errors explicitly. Because the only person who knows what the right thing is to do when something fails is the person who called that function right there. That's the only person. That's why exception handling in C++ is stupid. That's why this functional language way of stringing lots of things together is bad. Because to handle a failure, you need to know what the failure was. You can't sweep it under the rug and ignore what failed. So I don't think that that's a good tradition. No, I think it's very bad. Will you use SIMD intrinsics? Will there be a less painful way of switching between AOS and SIMD SOA? Yeah, we had some SOA support before. That is deprecated for now, but we'll bring it back eventually. We don't have SIMD intrinsics yet, but we will. We'll have a standard set of SIMD intrinsics for each processor architecture. I do not think that we're going to, well, I don't know. I was assuming that we wouldn't try to make general intrinsics that work most CPUs or everywhere. Like you could imagine having a float 4 that works on ARM and x64 or whatever. But Jeff was telling me that he thought that wouldn't be hard to do correctly, or at least usefully. So we're going to see. Maybe we'll try it and see how it goes. How much slower is compilation when a metaprogram is in the loop? It obviously depends on what your metaprogram does, but for metaprograms that don't do tremendously amounts of work, it's 15 to 20% probably. Any thoughts on filtering which fragments are fed to the metaprogram to keep compile time down? Yeah, I mean, we already have one option for that, which is there is an option to only send the metaprogram messages about declarations that have notes on them, because the point of a note is you want the metaprogram to look at it, right? So you have two modes. You can look at notes only or everything. That may not be good enough. So eventually, I mean, maybe you'll have per file control or something. I don't know. We'll have to see what people want and what makes sense. Do I have any New Year's resolutions? Yes, to release the compiler this year to at least a moderate size of people. Will there be some way for procedures to enforce that the calling code handles their error conditions? There is, way back, when I first implemented multiple return values, so you could find the video by that name on YouTube, there is a hash must directive that says that, for example, if you return a success value, the caller has to at least assign that to something. It can't ignore that value, as you can normally with return values. So then at least it'll be there in the code, and then, you know, like lexically somebody may notice that it's not being used. We don't force you to do anything with that yet, and I don't know what makes sense there. But you could, in a compile time metaprogram, enforce that something happens with that if you wanted to. Will I target any SOCs, i.e. mobile? Yeah, sure. Eventually we want to target everything. It's just, you know, one step at a time. One step at a time. Let me take out my atomic here since the compiler doesn't understand that yet. Whoops. Thanks, I'm glad you like it. I've been talking for a long time, so I think I'm going to sign off now, and I might play video games for an hour. We'll see how that goes. How do you handle GL get error? Well, right now you just call GL get error, just like before. Like, I don't like the way GL get error works, but it's the OpenGL API, right? So I'm not trying to change the way things work for APIs that already exist, but if you're making a new API, we can make it, encourage better things. Like for GL get error, you could put a hashtag must in front of the return value. That'll link just fine because it doesn't change the calling convention at all. It's just, why would you call GL get error if you're not paying attention to the return value, right? Have I considered creating an online redevel print loop? No, I don't think redevel print loops are any good. Compiler size. Probably about the same as last time I tweeted, a little bit bigger. Unless I have some junk files in the folder. 39652 lines. Thanks, Joe Sweeney. Yeah, it makes me excited to program too. Compiler binary size. I don't know. We're not exactly. Wait, where is it? x64 release. 14 megs, which seems really large, but I guess that's. We're not optimizing for size, certainly. And I guess that's what x64 binaries look like these days. It's only a 40,000 line program. I don't know, man. Maybe something dumb is happening there. Will the compiler ship as a statically linked single library binary? Probably, yeah. I mean, we may give source code to people as well, but we're not going to require people to compile it. Unless you're on one of those operating systems where shipping a binary sucks, then maybe we'll have you compile it, but eh. How's the tag union thing going? I decided not to do it for now because it didn't cover enough of my use cases. I actually was going to talk about that during this demo, but I didn't. So no plan for tagged unions in the near future, but we may do them eventually. Yes, there are plans for inline assembly. It's not going to happen for a little bit because writing an assembler is a pain in the butt. The status of the SOA replacement is not yet. It's working. It's waiting on a big feature that has to go in first. So not for a while. If we don't ever do that, there's a fallback where we re-implement SOA kind of in the old way but different. So we'll see. How hard would it be for someone to write their own implementation? I don't know. I mean, there are people who have done things that are similar but maybe don't have all the features and made different choices. So like Ginger Bill has a language called Odin that I think is inspired by this, but he has different opinions about what's important, and so it goes in a little bit of a different direction. I don't know. I mean, you can judge by the features how hard you think it is to implement this, and then of course keep in mind it's probably at least 5 times as hard as you thought, because that's how programming is. I don't want to keep talking about SOA because I've said it like 5 times on streams. Do we support dynamic libraries? Yes. Can you reload it at runtime? Well, I mean, that's an operating system feature, right? If you mean can you do edit and continue, we don't do that yet, but we probably will, yes, by compiling to dynamic libraries and reloading those. It's just we haven't done that yet because compile time is so fast that you don't save much by doing that. You save the setup of your program state or whatever, but you don't really save much. If someone wanted to do tag unions, could they do it without metaprogramming? I don't know. Possibly. You'd have to think about it or experiment in some way. Like with a run directive, you definitely could do it. It's just you'd have to type #run somewhere. Once we have macros, then that could be hidden from you, and maybe it would be kind of reasonable.